Block level storage is great, but there are certainly other ways to achieve a location for shared data stores. NFS is another one of those ways that is a file level storage mechanism that is accessed through TCP/IP. Let's have a look at lesson number 5, NFS Datastores. We'll look at NFS in a similar way that we looked at iSCSI. We're going to look at the components of an NFS infrastructure. We're going to look at the differences between the two versions of NFS that ESXi supports, that is NFS version 3 and NFS version 4.1. Once we understand a little bit about NFS, we're going to have a look at the way that we configure and manage NFS data stores. It's really super simple to do, and it does require, like iSCSI, a VM kernel port on each of your ESXi hosts. So let's dive right in. So here are NFS components. This is file level storage. So think of an NFS export as simply a file share that is being created on a storage array or in an NFS server somewhere available on the network that your ESXi hosts have access to. We're going to create folders on that NFS server, and then we will share them out to ESXi. ESXi will see that folder, it'll call it a data store, and begin putting virtual machine files on that particular data store. So on my ESXi host, right here, we have a virtual switch. That virtual switch has a VM kernel port on the same network that my NFS server is on. Once again, it's going to grab the first network that it sees, that it has the ability to see that NFS server on. So keep your management network, for example, and your NFS VM kernel ports physically separated, either by using a completely separate network, separate physical NIC, for example, or by using VLANs. Okay? Once that VM kernel port is created, you'll build a data store simply by pointing to the NFS server on your storage array or machine that is connected to. Once you see that machine here, accessed by its fully qualified domain name or its IP address, you'll point it to the folder that has been exported or shared with ESXi, and voila, we have a data store. Now, there are a couple of different versions of NFS, like I said before, that are supported by ESXi. There's NFS version 3, which has been around forever and ever and ever. And then there's NFS version 4.1, which is a little bit more advanced. Let's compare the two a little bit here, but there's one simple takeaway here. If you create an NFS data store, or if you create, I should say, an NFS server or share that supports both NFS 3 and NFS 4.1, you need to make sure that you only access that NFS share using one single one of those particular versions of NFS or protocols. So all of your hosts need to access that NFS share with the same version of the NFS protocol. They should all either use NFS 3, they should all either use NFS 4.1. That's really relevant if you have an NFS share that supports both protocols at the same time. Okay? Make sure you only use one of those protocols. Now, NFS 3 has a few drawbacks, okay? But it is very, very simple to set up. ESXi is going to manage all of the multipathing with NFS 3, okay, by using VM kernel ports with IP hash-based load balancing on two separate, on a single VM kernel port with two separate physical cards connected to it. Okay? The other thing is the access or the authentication method that ESXi uses to connect to your NFS share and authenticate itself is called authsys. ESXi says to the NFS share or the NFS server, I'm root, allow me to access it. Okay? A lot of folks don't like that, and so they try to discourage that. If that's the case, you're going to want to use instead NFS 4.1. Now, we also have to have some sort of mechanism for locking files to a single ESXi host for a particular virtual machine. You don't want multiple ESXi hosts trying to power on and write to the same virtual machine disk at the same time, right? So there has to be some sort of locking mechanism for any sort of data store. Now, with VMFS, that's built into the VMFS file system, or I should say format. But with NFS 3, there is no locking mechanism that is native to NFS 3. So VMware has to manage it on its own. Okay? It does it by using a .lck file, and the presence or absence of that file tells ESXi hosts whether or not they're allowed to grab on to the file and power on the virtual machine. Also, in terms of error tracking with NFS 3, there's nothing that's done on the NFS server itself. It's all done on the ESXi side or the client side. Now, on the other hand, with NFS 4.1, there is native multipathing and session trunking solutions for NFS 4.1 that we can utilize. And we'll actually show you how to do that from the ESXi side of things itself. In addition to authsys or root authentication, we can also use Kerberos-based authentication by creating a service account in Active Directory and using that service account to authenticate against an NFS file export. That's actually configured on the ESXi side of things. We also manage all of the locking mechanisms natively within the protocol, as well as all of the error tracking, and it's all done by the NFS servers instead of relying on ESXi to manage that side of things. So if you have the capability of using NFS 4.1, there are definitely some advantages to that. And if they're important to you, well, we support it with ESXi. Now, the fact that we have shared storage here with both NFS 3 and NFS 4.1 brings us a really long way to making sure that our virtual machines are completely portable. They can run between any of the ESXi hosts. Right? We can storage vMotion, and we can do all of those really nice features with both of these protocols that we would like to do. There are just a couple of exceptions to NFS 4.1. NFS 4.1 does not support storage DRS, or I should say it the other way around. Storage DRS and storage I/O control do not support NFS 4.1. Neither does Site Recovery Manager, does not yet support NFS 4.1. So if you want to use these features, you might choose to use NFS 3 instead. So configuring an NFS data store itself is a simple thing to do. The first thing we're going to do on each of our ESXi hosts is go into the networking section and add a VM kernel port. And we're going to make sure that that VM kernel port is separate from things like our management traffic and our iSCSI traffic, either with separate physical networks or by using VLANs. Then we go back to the data store view, right-click on our data center and select New Data Store, just like we did in the previous lab. But this time, we're going to select NFS. It's going to ask you what version do you want, 3 or 4.1. Then I'll give it the data store name, point to the NFS server, point to the NFS export or the NFS share by selecting the folder name, choose the hosts that you would like to mount the data store, choose the option of whether or not to mount it as read-only with a simple little checkbox, and then choose how you want to authenticate against it by either using the service account or by using root. If you do want to use a service account to authenticate using Kerberos against an NFS export, NFS 4.1 export. You're going to configure that service account, first of all, in Active Directory. And then you're going to come over to ESXi and look at the authentication services link on your ESXi host. It's under Configure. Now, this allows you, first of all, to have your ESXi host join your Active Directory domain, which you will want to do. From that point, you scroll down and choose the NFS Kerberos credentials that this particular ESXi host is going to use to authenticate against all NFS 4.1 data stores that might be mounted to this host. It's not a per data store set of credentials. It's done on the ESXi side, and it's a single credential used for all of the data stores that are available. So you'll add the username and password of that service account. Then, once you create the data store, you've chosen NFS 4.1, you can choose to use Kerberos for authentication or Kerberos for both authentication as well as data integrity. There's a couple of features that you have to enable on the Active Directory side in order to enable Kerberos with authentication, but you can check out the Microsoft documentation for Active Directory in order to do that for Kerberos authentication on a particular user account or service account in this case. Note that it is the same credentials that you must configure across all of the ESXi hosts that are going to be mounting this particular data store. You cannot have separate credentials per host. It's the same credentials on each of those hosts. Of course, we've shown you how to build the NFS data store. It's also important to know how to unmount that data store. Now, when it comes to VMFS, because it's block level storage, ESXi has the ability to be destructive of the data, and that is to delete the data store itself. But when it comes to NFS, being a simple file share, ESXi doesn't have the ability to delete the file share. Okay? So there's no delete data store under NFS. There is the unmount data store. And just like the VMFS side of things, you may have to make sure that there are no virtual machines on the data store before you unmount it. Now, when it comes to multipathing with NFS storage, there's a couple of ways to do this. First of all, configuring a single VM kernel port and then attaching multiple NICs, right, to the same switch, enabling IP hash-based load balancing on the VM kernel port with at least 2 different physical NICs, and on the physical switch side of things, using 802.3 AD link aggregation control. On the switch, you have to make sure that you use 802.3 AD link aggregation control as well. Okay? This way, with IP hash-based load balancing and 802.3 AD LACP, you're able to make sure that your ESXi host has multiple paths available to it to your NFS storage array itself. In order to use NFS multipathing for NFS 4.1, it's an easier thing to do. You simply will add multiple destinations, multiple IP addresses to your NFS, to the location of your NFS server. So as you build the data store, simply add multiple locations here. You can add them and hit the plus button. You can add multiple at a time, separating them with commas. That way you actually have multiple remote destinations available for you. Well, it's time to finish up this lesson with a very simple lab that has you configuring access with a VM kernel port to the NFS data store, building the data store simply by pointing to the NFS export, and then coming back to ESXi, making sure that you can actually see that data store. And that winds up our lesson on NFS, where we looked at the different components of the NFS data store. We learned about the different ways that we can build NFS data stores and the difference between NFS 3 and NFS 4.1. And now we have learned how to configure and manage those data stores as well. When we come back, we'll have a look at vSAN data stores. Hyperconverged storage is a really neat technology. We'll see you soon.